Okay, now next one, we're going to have the speaker. I think many of you might be familiar with him because you will see himself explain his product in person, okay, one by one. He's Dominique Courbin. Okay, he's the Chief Operating Officer of Limbitless Solutions, and the company is to help produce bionic arms for children in need. 在3D 列印，昨天我们看了小提琴，还有萨克斯风之外，今天我们又来了一个钢铁人的仿生手臂，让我们来欢迎 Limbitless Solutions 的营运总监 Dominique Courbin。
你好，台湾。So that's the only Chinese I know, so we'll keep going in English. But first, I'd really like to thank the MIC and everyone involved with DOIT Taiwan for inviting me and having me here. It was a very, very beautiful experience, and I look forward to returning to Taiwan soon. So I can spend a lot of time explaining what it is that Limbitless Solutions does, but I'd like to just show a video, and then everybody can be up to speed.
So I'm just going to go down here. We're looking for 912.
Hey Alex, how are you? Pleasure to meet you. I have another bionics expert on hand, so I thought I'd drop by.
Thank you.
Yes, a pleasure. Nice bow tie, by the way.
Thanks.
How were your travels?
It's very good.
Well, I thought I'd bring one of my gauntlets and match it up with yours and see if everything's copacetic. You want to have a look?
Sure.
Ready?
Yep.
Great.
Each one looks the same.
Actually, I think yours might be better than mine. What do you say we both try them on, do a progress report?
Okay.
You know who that is?
Iron Man.
What's his name?
Robert.
Great. God, dude, it's even cooler than I thought. I'm having a technical glitch. As you can see, my light isn't working. Half the time, you know, I design one of these, it winds up breaking on me. But what I do is I keep working on it, kind of like you're working on it with Albert.
He keeps working and working until he gets it right.
Yeah, I think yours is still a little bit more right than mine because at least, you know,
The lights work.
your light works, yeah. Ah, look at that, dude. It's a marriage of robotic technologies. Bang, nailed it. Love it. Hey, good job, Albert.
Thank you, sir.
Yeah.
Appreciate it.
Albert has made it so affordable. I'm probably going to start farming out a lot of my tech work to Albert, too. I feel like he could cut the price point down on one of my suits, which right now is, I guess, about, I don't know, $1.5 billion.
So, thank you. 谢谢, 谢谢. So about a year and a half ago, we started as a group of individuals. We began when Albert, as you saw in the video, a co-founder of mine, was driving home, or driving to work, excuse me, and he heard on the radio about a beautiful organization called Enable, where they 3D print mechanical hands to replace fingers for children or people who have lost them in an industrial accident. We were very influenced by this story that we heard about Enable. Ivan Owen and Richard Van Oss, they co-developed the very first 3D printed hand. And when we got more involved in Enable, we were paired with this young man, as you see on the screen, Alex Pring. Unfortunately, his condition didn't allow him to use any of the mechanical versions. And so we began exploring alternative options to help him and other people like him. In the very beginning, we knew that we wanted to have the device developed for less than $500. We wanted it to be able to be actuated or used by the arm that was affected independently. We thought that if we had to use our dominant arm to control the non-dominant arm, then at the end you were at the end, you had less functionality than when you began. So we didn't think that that was quite effective. And the beauty of 3D printing is that it can be rescaled to fit the child as they grow. Currently in the United States, insurance companies don't enjoy paying for multiple prosthetics. So children, as they grow, it becomes very expensive, and prosthetic companies will not cover them. So then we also said that we wanted it to be appealing to the children. We didn't want it to look like a monstrosity so that the children wouldn't wear it. And so in the very beginning, this is what we set out to do. And within about 8 weeks, we had developed our very first arm. The very first arm, you can see here, it was kind of blocky. It wasn't very clean or very sleek, but we did the best that we could. And so we also wanted to use a muscle sensor. So as I said before, we didn't think it was a great idea to use one arm to control the other. And so I can demonstrate for you now that when I flex my muscles on my right arm, the arm here will also actuate. So we thought that it was a beautiful technology. What it does is it measures the voltage within any targeted muscle group. So right now I have it on my forearm, but I can put it on my bicep, on my chest, on my abs, anywhere, and it will work the same. So we also wanted all of the electronics to be low cost and highly effective. So we scoured the market, and we found as many electronic components that were very inexpensive and fit our design the best. And at the end of it, as I said, at the end of the 8 weeks, we developed our very first arm. And we were very proud. We had accomplished something that had never been done before, a 3D printed bionic arm using EMG technology. And in the end, it cost less than about $350. And here we have a quote that no one should profit monetarily at the expense of a child needing an arm. And we still feel that to this day, we cannot request a monetary compensation for a child being born with a condition. We just don't think that that's morally applicable. It doesn't feel right. And so not only did we develop it, we gave it away. So we gave our very first arm to Alex, and we also gave away the plans. We made it open source, and we encouraged anybody in the world who could to help contribute to make it better. At this time, we were flooded with requests. We became very popular on the news, and we were just also very pleased by the impact that we had made. So it wasn't very long until we saw that there was a young girl in Virginia who also needed an arm. And what we saw is that we would really like to make a lot of improvements. The very first arm was kind of blocky, and we thought we could do a lot better. We also wanted to make it a fairly modular design because that allows us to change things very quickly, and it allows us to use the same components for as many arms as possible. So the young girl needed a very different solution than Alex, and so we did our very best to shrink the electronics to offer some of that modularity, and then also to customize the sleeve for the little girl. And this was it. So ultimately, we made this very beautifully painted, tangled, themed arm, and we had experimented with some coupling, different coupling mechanisms, and eventually we found this really beautiful way that it could be worn for the young girl. And then, for the very first time, she held both of her hands of her mother, and that was a very moving experience. And this happened just before a very American holiday, Thanksgiving. And so she was able to enjoy her first Thanksgiving meal with two hands, and it was just all in all a very beautiful experience. But then I went back and saw Alex. I visited him one day, and he was still wearing his very blocky arm. And from some of the attention that we had gained from all of the news and from all of the success that we had received both with Madeline's arm and Alex's first arm, we were very blessed to have teamed up with Microsoft to do some commercials. And through part of the participation with Microsoft, we met some very important people and some people who had some very good connections. And so it was at that time that we were able to talk to Robert Downey Jr., to talk to Iron Man, about producing an arm to give back to Alex because he had gone through such a journey with us. And so we wanted to really give back to him all of the advancements that we had made in the past 6 months and really give him an experience that he would cherish forever. And so today I have Alex's advancements and the arm that he has and wears to this day. The elbow on the first arm was fixed, and currently he uses a mechanical elbow. So he can place the elbow wherever he wants with his organic arm. Oh no. And then he can actuate the arm using the EMG. The electronics, the battery lasts about 8 to 10 hours, so it's an all-day thing. He charges it just like a cell phone using USB, and it's a seamless design. In his first arm, he was required to remove the batteries to charge them. So this was a huge advancement for him. It was much easier for him and his family to charge the arm. And it was Iron Man. What kid doesn't want an Iron Man arm? Yeah, so if I could, I'd wear this thing. It's awesome. So where are we going? In the future, we've produced 6 arms. In the past, there are 6 children who use our arms today, and more counting the mechanical versions that we do in partnership with Enable. So this year, this December, we'll be producing 12 arms given to 12 very special children for Christmas. And our target for the entire year from July to May of 2016 is 50 bionic arms total. So what that means is that it takes a lot of time to train teams to be able to produce these arms. And right now, as part of those 12 arms, we're training 12 independent teams to make them. So after that, we're then able to use the 12 teams that made those 12 arms to train another 12 teams. And so through this kind of organic growth, we hope to be able to produce more and more arms and spread that growth to more and more places. And then to pay back to where we came from and part of the Enable community, we'd love to continue to produce the mechanical hands that work very well for the people that need them. And so our target for the mechanical hands is about 100 arms, 100 hands. So there are multiple ways that people can get involved. You can always visit our website to see what we're up to and how we're continuing. We are on almost every social media. We're on Facebook, Twitter, Instagram. We also have a Snapchat that's new. I am not very experienced with social media. I prefer face-to-face. So it's other people on my team that definitely handle this stuff. And if you would like to see a lot of our videos and many of the other things that we've done, 3dhope.com is a great place to visit. And we wouldn't be here today if it weren't for the people who've helped us to get here. So Microsoft, Nemours, Advanced Technologies is the producer of our EMG chip. And everyone else, Stratasys is the printers that we use. We wouldn't be here today. And we're going to have to add MIC and DOIT to this slide because without them, we wouldn't be here and have visited to Taiwan. We thank you again. Thank you so much. So before I finish, I would like to invite Laurent up to the stage because I think that one of the beautiful things about what we do is that collaboration, is exposing ourselves to new people and having new experiences. And as part of DOIT Taiwan, I was able to meet Laurent, and we've amused ourselves a whole lot with what we've been doing today. He 3D printed his violin, and the arm is also 3D printed. So I thought it would be a beautiful experience to collaborate here.
Yes, we can try it.
Yes. So I'll hold the strings while Laurent, he plays a beautiful violin.
Oh.
Even better, huh? Thank you, Laurent. 谢谢 Taiwan.
Thank you.